Good morning, students. In last session, we have seen about we have discussed related to the gas phase synthesis of nanomaterials. In that, we have come across the Joule heating and laser ablation for heating the metal in a refractory crucible by two methods. One is by Joule heating, where heating of the metal above its supercritical temperature or above its critical temperature, beyond its melting temperature, so that it converts to the vapor phase. In the same way, other method is by laser ablation technique, where heating the metal above its temperature so that the metal vaporize. So when we are having a metal which is having a high temperature than the crucible metal, the crucible which is manufactured by the metal. So the crucible temperature, so when the metal, that is the precursor which we are using, that precursor is having a high temperature than the crucible, at that time we cannot use the Joule heating method. So at that time we have to use laser ablation technique to heat the metal. So what do you mean by laser ablation? So in today's session I am going to explain what do you mean by laser ablation. So laser ablation is one of the technique to synthesize nanoparticles. So all of you are knowing what do you mean by laser. Students, laser, which is nothing but a light amplification by simulation emission of radiation, and ablation is nothing but removal, or it may be the emission. So here ablation is nothing but the removal way or emission. So the particle has to vaporize, or it has to emit, or it has to absorb. So here nanomaterials and nanofilms are manufactured, or synthesized. Nanomaterials and nanofilms are synthesized by the laser ablation technique. So it is a very, very important technique, because the nanotubes, carbon nanotubes, it may be the single-walled or it may be the multi-walled nanotubes, which are synthesized by laser ablation technique. So because of this, it is very, very important technique what we are having. So this laser ablation technique, which comes under the gas synthesis of nanoparticles. So we are having solid, liquid and gas, synthesis of nanoparticles by solid, liquid and gas. So in solid we are having agitated ball milling, lithography, which we have discussed in our last class. In our last discussion we have discussed about this one. In the last these classes or the discussion, we have come across liquid, that is the wet chemical synthesis of nanoparticle, or sol-gel method. Sol-gel method we have discussed. So in the same way we are having co-precipitation, solvothermal synthesis. So like this we are having different techniques, but for our syllabus we are having only sol-gel technique. So we have discussed this one. In a gas synthesis of nanoparticles, we are having chemical vapor deposition, laser ablation technique, flame pyrolysis, so inert gas condensation and sputtering. So for our syllabus we are having chemical vapor deposition as well as laser ablation we are not having, but we are having flame pyrolysis. But because we have to come under gas synthesis of nanoparticles, we are going to discuss about the gas synthesis of nanoparticles, where metals are heated by laser ablation technique. So because of this, what we should know what to be by laser ablation here. So because of that I am going to explain this laser ablation technique. So laser ablation technique, which comes under the gas synthesis of nanoparticles. So here this laser ablation technique, which uses laser here, which uses laser beams. Laser beams are used. So first we'll see how exactly the process works here. So in laser ablation technique, removing material from a solid surface, removing material, that is ablation is nothing but removing material from a solid surface by irradiating it with a laser beam. So by the laser beam we are going to remove the material from the solid surface. This we call it as laser ablation technique here. So at a low laser flux, the material is heated. So here the heating of the precursor is done by laser beam. So heated by the absorbed laser energy and evaporates or sublimates. So here by the laser beam the material is heated and it converts to vapor form. So it and evaporates or sublimates at the high laser flux. The material is converted to a plasma state here. So at the low laser flux the material is heated, but when it comes to high laser flux, the material is converted to a plasma. So gas condensation to produce. So after the evaporation, after the vaporization, when the metal converts to vapor form, the vapor form of the metal has to be condensed. It has to be cooled. So gas condensation. So by the carrier gas, by the inert gases, we are going to condense. So gas condensation takes place here. So by the carrier gas, the condensation is made. So gas condensation to produce nanoparticles of metal, that is metal oxide and metal carbides. So when we want the metal oxides and metal carbides, we go by this laser ablation technique here. So this is what we are having, the laser ablation. So you can see the three figure. The first figure which indicates the substrate we are having, that is the target, the laser beam which is targeted, and it converts to vapor form. The vapor form which will be accumulated in the substrate, on the substrate, that is deposited film. Substrate is nothing but where the vapor form is deposited. So that is what the third figure which indicates here. So laser ablation, in laser ablation process, pulsed razor is nothing but high energy pulsed beam of rays, that is of 10⁷ watt per centimeter cube at high temperature. The laser beam which vaporize the target material. So the precursor material which is vaporized by the high energy pulsed beam, which is having 10⁷ watt per centimeter cube, the high temperature. So the desirable that is removed, that is the desirable target material which is removed, where it converts to the molecules, the target molecules. So the vaporize a graphite target in a high temperature reactor while an inert gas is blended into the chamber. So when it vaporizes, the figure you can see the target, when the laser beam targets the material, it vaporizes, and this vapor form of the metal, has to carry it to the condensation chamber. So to carry this to the condensation chamber, we use inert gas. So inert gas which is blended, that is inert gas which is used to convert to the nanoparticles by the condensation process here. So and it vaporizes the carrier gas which takes the vapor metal to the condensation chamber, where by the coolant which is fed in the coolant, where the condensation takes place. So by the condensation, the material which converts to the nanomaterial, that is the liquid droplet which converts to by the condensation which converts to the nanoparticles. So these nanoparticle is nothing but the metal oxide. So nanotubes developed on the cooler surface of the reactor, as the vaporized carbon condense here. So when we talk about the carbon nanotube, it is a single or it may be the multi-wall nanotubes. So at that time the target material will be the graphite. So here whatever you are going to see, it is with respect to the carbon nanotubes where it is synthesized. So graphite is the target material. So with respect to the graphite material, the 1% of cobalt or it may be the nickel which is added as a catalyst, for this target material. So when a laser beam is impact, or when the laser beam which emits or vaporize, when the laser beam falls on this target material, it vaporizes, and it takes the vapor metal which carries to the condensation chamber where it is cooler surface. It takes to the cooler surface where it is condensed and it converts to the carbon nanotubes. So this is what we are having, a laser ablation technique, which is very important technique with respect to with respect to the carbon nanotubes, because carbon nanotubes plays a very important role in our aircraft field, in the automotive field. So carbon nanotubes, which are very important. So these nanotubes which are manufactured by using laser ablation technique. So you can see the figure here which illustrates the process of the laser ablation. So the NDYAG laser. So NDYAG laser, which is nothing but the laser beam. So laser beam which falls on the target material. So high temperature pulsed beam of rays which is having more than 10 raised to 7 watt per centimeter cube with a high temperature, where it falls on a target material, that is a solution. So when it falls on a target material, the material vaporizes. So we are having mirror, lens, glass container. So when it falls on the target material, the target material which vaporize, and these vapor metal which carried by the carrier gas to the condensation chamber, where it condensed, it is cooled in terms of the nanoparticles. So laser, that is the shock wave plasma. So the target material, so it goes to the bubble. So next you can see it is a bubble or the target, where the target material which vaporize and it converts to the nanoparticles. So this is the figure which indicates the laser ablation technique. So you can see here, so the laser beam which falls on the target material. So it is a vacuum chamber, which is connected with the inert gas, carrier gas, that is a gas inlet. What we are having with respect to that, we are having a vacuum pump. So vacuum chamber, so dynamic vacuum we have to create inside the chamber. So we are having the carrier gas, the gas inlet, which has having a vacuum pump to pump, that is to send the carrier gas into the chamber, and as well as to remove this inert gas, we are having a vacuum pump also to create a dynamic vacuum. So we are having a target. So when a ray of beam, when the laser beam falls on the target material, so the material which will be ablated in terms of vapor, so which will be collected on the substrate, so which is collected on the substrate, which is nothing but which is cooled in terms of nanomaterials. So it converts to the metal oxide. That is the ablated vapor which collects on the coolant. So the substrate is nothing but it is a coolant. What we are having, the metal, the vapor which will be collected on the substrate, that is a coolant, which where it cools, which condense, and it converts to the nanomaterials. So in terms of metal oxide. So this is the process what we are having in the laser ablation technique. So this is also the figure which indicates, so where laser beam falls on the target material, the metal plate, where we are having a liquid. So it is control, which is in control what we are having. So in this process we can control the process. So in the sol gel technique, where we cannot control the process, the grain growth takes place. If we want to control this, we have to control the evaporation technique, that is a vaporization. We have to control the condensation, we have to control the conversion, so all have to be made. So the controlling of the process in sol-gel technique is very difficult. That is, a grain growth takes place in the same way. To stop the grain growth, it is very difficult. But in the gas condensation process or in the laser ablation technique, we can control the process very easily by the laser beam. If we stop a laser beam, automatically the process is controlled. So here the laser beam or the gas condensation technique, in the gas condensation technique also we are going to have a heating by Joule heating or by the laser ablation. If we can control the process very easily, we can control the process very easily by this gas condensation technique. So here we can control the process very easily. This is a very advantage of the gas condensation process with respect to the wet chemical process or the sol-gel technique. So sol-gel technique cannot be controlled very easily, so it is a very disadvantage of that process. But it is an economical one, but it is having a disadvantage of the controlling of the process. But the advantage of the laser ablation or the gas condensation technique is the process can be controlled very easily. So this is what we are having: laser beam, the flow to high temperature furnace, high temperature argon gas which is passed through. We are having a graphite catalyst. We are having a graphite catalyst, cooled nanotube catalyst. Cooled nanotube, synthesizing nanotubes. It is synthesizing the nanotubes. So laser beam which falls on the graphite material, it converts to the vapor form. So it is condensed and we get the carbon nanotubes. This is the process, the same process it is having. So these all are with respect to the laser ablation technique. So these all are the process with respect to synthesis of nanoparticles by using the laser ablation or by gas condensation process. Thank you, students.